Now here's a sample problem that correlates to an inclined plane. It's got a block of mass 250 grams. It is pushed up, so there's an additional force. It's not just this situation. There's an additional force pushing up the ramp. Frictionless inclined plane angled at 23 degrees above the horizontal by a force that is parallel to the plane. Okay, so that means that force is only in this x direction. There isn't any component in the y direction. Block moves at constant speed. What is the magnitude of the applied force? Okay, well, always want to draw a diagram. Got our object on the inclined plane. What forces are acting? So gravitational, normal, and then there's this push. Force push, or FA for F applied, or whatever you want to call it. And we know the block moves at constant speed. What does that tell us? Constant speed means that our acceleration is 0, meaning the net force is 0. So, well, once again, we can write Newton's second law in each direction. In the y direction, this is what we got. Same thing, because this force is horizontal. But this doesn't really have any bearing on the answer to this question. So, in the x direction, what do we have? We've got the push going up the ramp. And if I stick with calling down the ramp positive, then that would be a negative. And then, just like we did over here, we have mg sine theta going down the ramp. Set that equal to ma. And then doing a teeny bit of algebra, we can see that the magnitude of that force is equal to mg sine theta minus and ma, our acceleration is 0. So the magnitude of the push is equal to mg sine theta. And then we can plug in numbers. 250 grams is 0.25 kilograms. G is 9.8 times sine 23. 0.25, 9.8, sine 23. And we get that the magnitude of that applied force is about 0.957 newtons. Okay. Same block accelerates up the plane at 2.1 meters per second squared. Well, this is exactly the same situation, except acceleration is not 0. So mg sine theta minus the pushing force is equal to ma. Pushing force is equal to mg sine theta minus ma. And then we plug numbers in to calculate the magnitude of the pushing force. Alright, accelerates up the plane at 2.1 meters per second squared. Okay, I called up the plane negative, so I have to plug that in as a negative 2.1. It's tricky to make sure you're being consistent in your signs. And this makes sense because if it's being pushed up the ramp, we know that it should be bigger than it was when it was just, if it's accelerating up the ramp, we know the force should be bigger than it was when it was moving up the ramp with 0 acceleration. And we can see we're going to be increasing the value by subtracting a negative. So plus 0.25 times 2.1. And now the force is about 1.482 newtons. All right. So those are some examples, explanations: normal force, frictional force, inclined plane. All of these things are things we're going to use over and over and over and over again. I would recommend that you make sure you get them down the first time around.